Welcome to the HPC Best Practices webinar series. This series is brought to you by the IDEAS Productivity Project, which is part of the Exascale computing project of the United States Department of Energy. The series is a collaboration involving the computing facilities at the Argonne, Oak Ridge, and Lawrence Berkeley National Laboratories. I'm Osni Marquez from Lawrence Berkeley, and Ashley Barker and Ashley is from Oak Ridge, and I will be the host for today's webinar, Scientific Software Ecosystems and Communities, Why We Need Them and How Each of Us Can Help Them Thrive. It's a pleasure to have Lois Kaufman-McInnes with us today to present this webinar. Lois works at the Argonne National Laboratory, where she's an Argonne Distinguished Fellow in the Mathematics and Computer Science Division. Her work focuses on high-performance computational science, especially on scalable numerical libraries and community collaboration toward productive and sustainable software ecosystems. She serves as Deputy Director of Software Technology for the Exascale Computing Project, and she also co-leads the IDEAS Productivity Project. We have issued 140 tickets for today's webinar, and all attendees have been muted. We'll be receiving questions through the Zoom chat and also the Google Doc. We have pasted the address there in the chat. We're going to do it again. And the webinar will have breaks so the speaker can respond to the questions that come in. With that, Lois, I will stop my sharing.
Thank you so much, Osni, and thanks everyone for coming today. I'm looking forward to having an exciting conversation, and I encourage people to really do dive in and ask questions. So I will first mention that what I'm presenting today is based on a presentation that I did at Supercomputing recently, and I am excited to build on Supercomputing's theme of science and beyond. The conference and the work in our community has been showcasing the phenomenal impact that computational science has been having on our world. And indeed, computational science is recognized as a third pillar of scientific discovery, along with experimental and theoretical research. Typically, our community focuses on science advances. Showed in this slide are some science advances underway within the Exascale computing project across a range of topics, including energy, chemistry, materials, earth and space science, national security, and more. I encourage people who are interested to dive into the website for the Exascale computing project to learn more about applications. Our community also often talks about advances in computer architectures that enable these applications, as well as advances in computer science and applied mathematics, such as new algorithms at scale on emerging heterogeneous architectures, all very important to underlie these new capabilities. But what we don't often talk about is the importance of high quality software as a critical element of these scientific achievements. And I believe, and I think many people in our community believe, that in order to truly reap the rewards of computational discovery, we as a community must focus on the fundamental role of high quality software in all that we do, and to think about it from the point of view of communities of people who develop that software and ecosystems of software, and how each of us can contribute to helping those thrive. As I was considering how to approach speaking about this topic, I happened to be doing a walk in my neighborhood, listening to an Audible book by author Ann Patchett. Her topic was very different from this. Not a science topic at all, but a complex topic. And as she was speaking about the complexity of her subject and how multiple lenses are needed in order to understand complex subjects, it occurred to me that element, that lens is appropriate here too for high performance scientific computing. That is, there's so many wonderful elements to consider, but we each only focus on some part of that. And today, I'm going to focus on the lens of scientific software, and that is the importance of high quality scientific software of being our foundation of discovery and sustained collaboration. This diagram is part of a report that the SCIEM Activity Group on Computational Science and Engineering wrote a few years ago, and it attempts to show how software is indeed the way that we're encapsulating expertise across domains, across math, computer science, various domain areas of science and engineering, in order to make advances in computational and data-enabled discovery. And now is a really fun part of today, where I'm going to ask each person here to think about your relationships to scientific software. And I expect that for many of us, there'll be more than one way that you have a relationship with software. So think about what applies to yourself, and then we'll keep that in mind as we progress through the conversation today. So do you develop software, either that you use just for your own self or that you provide to others in your research group, or perhaps more broadly? Do you use software that other people develop? Do you contribute to teams who develop and use software, perhaps through helping with strategy, logistics, planning, fundraising? Do you lead projects or organizations where teams develop and use software? Are you a stakeholder or a supporter of projects that develop and use software? So I would imagine that probably each of us resonates with at least one of these, and I would hope that we all can see ourselves as being fans of scientific software. That's sort of a fun one. But I would posit that everyone in our world should be a fan of scientific software, whether they know it or not. So now let's pivot to a different topic, and that is ecosystems. Broadly speaking, an ecosystem is a group of independent but interrelated elements that comprise a unified whole, and the communal interaction among the elements of the ecosystem in their environment is what allows the system to function, and in some cases to thrive. This slide shows two examples of ecosystems. Ecosystems are pervasive. They're the backbone of our world. Here we see the human body's gut bacteria and also Australia's Great Barrier Reef. So let's consider some elements of ecosystems as we think about software. In particular, no element is functioning in isolation, and the whole truly is greater than the sum of its parts. So that'll be the focus of our conversation today. We'll talk about some complicated challenges, both technically and sociologically, and community efforts worldwide that are engaged in making progress to tackle some of these issues. We'll talk about ways that each of us can get involved with those activities. And then I'll dive into some work that we're doing in the Exascale Computing Project to tackle some of these challenges, in particular working on advances in ecosystems and software productivity. The article that's shown on the right here was written by the focus area leads in ECP, so it might be an interesting read for some of you. So before progressing further, I just want to thank the very many wonderful collaborators who have contributed to this work. What I'm speaking about represents the combined contributions of many, many people, and I want to thank each and every one of them for contributing not only to what I'm talking about here, but also my own development as a person, as a researcher over the years. And I especially want to thank the Department of Energy's Office of Advanced Scientific Computing Research for support throughout my career. Today, I especially want to thank our sponsors for the Exascale Computing Project and the leaders of that project, Doug Cothey, Director, and Lori Dyson, Deputy Director, who are really providing a wonderful foundation for multi-institutional collaboration to work on very exciting next generation science challenges. The Exascale Computing Project is one component of a multifaceted exascale computing initiative, and it is working to accelerate scientific discovery and economic competitiveness by maximizing the benefits of high-performance computing. So briefly, this is a multi-institutional effort started several years ago, and we're at a very exciting phase now where our teams are working toward new advances on new hardware. This is a collaboration across the DOE lab community and also with teams who are based in universities collaborating with us. So briefly, this is an aggressive research, development, and deployment effort that's focused on delivering mission-critical applications, as sort of summarized in the left-hand part of this slide, an integrated software stack that's represented by the center part of this slide. And indeed, that's where most of my focus is in software technologies. And then also by executing and integrating these advances on the newest emerging hardware. And that's represented by the right-hand part of this slide. So I'm grateful to partner with a wonderful team throughout the entire Exascale computing project. And my particular role focuses on serving as Deputy Director of Software Technology in partnership with Mike Haru, who is the Director of Software Technology. This slide shows in a little bit more depth some of the scientific applications that are being pursued as part of the Exascale computing project. I won't delve into these deeply here, but I do encourage you, those people who are interested, to read more on the website. And this slide shows our roadmap for computing systems, where we're in a very exciting time now with the new systems, Frontier and Aurora, on their way. And indeed, our teams are working on early access elements of those systems, and also working toward the new system, El Capitan, that will be coming to Livermore. So a key aspect of the computer architectures that we're working on now is that they are heterogeneous and they use accelerated computing nodes. So we've been building up as a community in this direction over many years. The diagram here on this slide shows how our complexity has been evolving from a time when we had only CPUs. So when we've been progressively advancing towards also incorporating GPUs, where we are right now is a very exciting time where we have these very diverse hardware configurations involving many computing vendors. So our teams are working very hard now, both at the high end, but I think it's important for all of us to recognize that these kinds of characteristics of architectures really are relevant for all of us. And we're working toward advances that should pervade our whole spectrum of computing hardware capabilities, from not only the large machines, but also clusters, desktops, and even laptops. So while we are developing new capabilities on new resources, we're working towards new kinds of science. This is perhaps some of the most exciting work that's happening now, as teams are thinking about how we can make good use of this new computing power to tackle new kinds of problems, not only multi-scale, multi-physics types of simulations, but also those involving sort of outer loop computations involving optimization, sensitivities, uncertainty quantification, as well as the coupling of more traditional simulations with those based on data analytics and learning, artificial intelligence. And indeed, there's even a lot of work going into thinking about relationships that couple workflows between computing facilities and other kinds of experimental and observational facilities within the Department of Energy. This slide was taken a diagram from a presentation by Ben Brown at a recent ASCAP meeting, and I encourage people to take a look. It's a really exciting representation of some new opportunities. All of these complexities mandate that we as a community need to think carefully about how to proceed in scientific software. So this slide on the right shows a summary of many of the challenges as articulated by Dan Katz in a presentation that he did several years ago. I think this is a nice articulation of our challenges across all sorts of areas relating to communities, sociology, technology, training, incentives, career paths, and all of these are intertwined together. There's no one that we can separate out and tackle it separately. The diagram on the left shows how our challenges increase across many axes as we expand the size of our computing machines, expand the complexity of our problems, expand the sizes and the aggregation of our teams who are working together, and also recognize that our software typically has a long lifetime, living over many years, and in fact, across many computer architectures lifetimes. So these are challenges that are some of them are technical, especially when we're considering on the research side that our requirements are changing as we're discovering new things, and the software is indeed very complicated. Some of our challenges are sociological, recognizing that we have a limited amount of time and funding. So we, as a community, collaborating across disciplines, need to make choices about where to devote our resources. And of course, while we're doing all this, we need to be cognizant of the fact that sometimes teams make choices based on their limited resources that cause the accrual of so-called technical debt. And that is what can happen when a more limited solution is chosen because it takes less time to take that approach rather than taking perhaps a sounder approach that requires more work. So considering our trade-offs is a complicated space, but something that we all need to be doing. What I personally find very exciting is that throughout the world, there are a variety of groups who have taken on in recent years tackling many of these challenges. This slide represents only some of those. I encourage people to take a look at these various groups, work of these groups, and the resources provided by these groups. And I'll call out just in particular the Research Software Alliance, which is an international body who is trying to promote the interaction among these groups. There are many, if you look at our Research Software Alliance's website, you'll see that there's many more activities beyond just those listed here on this slide. I'd also like to call out the Software Sustainability Institute in the UK, who has been a leader in the space of advancing software practices to help research and science, and also the very important research software engineering movement, which is advancing throughout the world overall. And in fact, there was a great workshop at Supercomputing on research software engineering. That would be a great place to go to look at information for people who are interested. So this concludes the first part of what I'd like to discuss today, sort of laying the groundwork for what some of our challenges are. And this would be a great place to pause if people have questions. After this, we'll move forward to talk more about software ecosystems and strategies to advance our productivity and sustainability.
Lois, I just see one person typing now, but please continue.
Okay, sounds good. So, as I mentioned, within the Exascale Computing Project, we are working to advance science goals, software technology goals. At the same time, we have a cross-cutting effort that is working to advance overall software practices as needed to achieve these goals. And what I show here in the bottom left graph is that we oftentimes have software practices that we're using for various elements of our work, such as testing, revision control, repository management, other things. And we recognize that if we want to make any change, of course, there's an investment in time. And then over time, the goal is that that investment pays off. And so what we're finding through our work with teams in the Exascale Computing Project is that we're able to have teams invest very carefully in making selected choices, improving impactful software practices to their own unique needs, their own unique pain points, so that then overall they can work more effectively to achieve more effective science, to use their time more effectively, and to help their software be more sustainable. So in order to give a more specific look at what is motivating our approach to software ecosystems in the Exascale Computing Project, I'm going to touch on the needs of just 5 applications within our portfolio. This is within a broader context of 26 applications and 6 co-design centers. But by considering just 5, we get a flavor of what we're tackling in this community project. So here we see 5 applications, one focusing on wind plant efficiency, another on subsurface flow, a third focusing on fusion energy plasma, a fourth focusing on cosmology, and a fifth focusing on a multiphysics explosive code. So they're very different applications being pursued by different teams based at different labs. This slide shows what elements of software technologies just those 5 applications are using or considering. And again, this is just a small slice of our overall portfolio where we have a much broader portfolio of both applications and software technologies. But even looking at just this small slice helps us to understand that our application teams are relying on multiple software technology products developed by our community. And some of those software products contribute to multiple distinctly developed components within a particular application. For example, in fusion energy modeling, where those multiple components need to run together as a single executable. So this helps us to understand why we really do need to think about our software from an ecosystem point of view so that we have consistency and can be effective. This slide introduces the work within the software technology focus area of the Exascale Computing Project, where our goal is to deliver high quality, robust software products in a way that complements what we're already getting from vendors and computing facilities, but developing specific functionality that our ECP applications need, and doing this in a way that makes sense to achieve good performance on our emerging architectures, but yet can be delivered in a way that meets the goals of both the researchers and the end application teams. Our software technology teams are working across 6 areas, as shown on this slide. And these 6 areas are led by 6 really outstanding people. It's such a privilege to work with the leads of our project, as well as with the teams themselves. So the community at ECP is developing functionality for programming models and runtimes, sort of lower layers of the software stack, as well as higher level functionality for math libraries, tools for data and visualization. Teams are also developing tools to help understand and improve performance. And in addition, our NNSA teams are contributing to our open software as well. So those are the 6 cross-cutting areas within software technology. This slide has way more detail than we want to focus on today, but it's really intended just to show you a flavor of the various projects. We have 34 teams who are contributing to developing 70 distinct software products that are being used in our ecosystem. These are led by many people within our community who are well known for their outstanding work across computer science and applied mathematics and high performance computing. This slide is just one example of the kinds of advances our teams in software technology are making. I'm not going to go into it in depth, but just to give you a flavor, we see that we have teams who are advancing algorithmically, for example, in math libraries, who are advancing sparse algorithms to take advantage of new architectures and new hybrid performance. We're seeing advances in compression as needed to handle huge volumes of data that are being generated on new machines, and advances in performance monitoring capabilities. What's interesting and certainly unique now as compared to our work many years ago is that all these software advances now are becoming available through a software ecosystem point of view, through the coordination of our work on software development kits and also E4S. So let me first introduce the concept of a software development kit by focusing on the work in the math libraries community. My own background is in numerical software, and for a time I served as the coordinator of math libraries in ECP and also the lead of the math libraries development kit, the XSDK. This is an effort by various teams within the math libraries community to coordinate their work in a way that enables them to function as independent teams, doing what they feel is most important and essential, but yet also to coordinate so that the complementarity of their work can serve the needs of ECP teams and the broader community. So shown on the left here are the libraries, some of which are funded by ECP and some of which are externally funded in the community that are now part of the latest release of the XSDK. Ulrike Yang coordinates the XSDK now, and Satish Pillai coordinated our last release. So we're seeing really nice advances by the teams in working in these communities to define how they can best move forward to serve their own unique needs for particular types of functionality. This slide shows how this software development kit perspective can be considered one layer of aggregation on top of individual software products. For many, many years, we've had very successful individual software products that have been making an impact in scientific computing. But now, because of these bigger challenges in coordinating problems, multi-physics, multi-domain problems, we're realizing that we need this intermediate level of aggregation. And then even beyond that, the E4S layer is helping us deal with the entire ecosystem. The Extreme Scale Scientific Software Stack, or E4S, is a curated approach to creating a high-performance software ecosystem. The key elements of this work are bringing together our community, using community policies to help guide what is common and what teams agree to do in order to support, to be part of being compliant with E4S community policies. So Samir Shen from the University of Oregon is leading E4S. And very importantly, we are building on top of SPAC, which is a software that helps with interoperability and portability installation to multiple architectures. SPAC is led by Todd Gamblin, and we have many contributors throughout the community who are helping to advance that functionality. So don't have time to dive into all the details, but I would encourage people to go to the E4S website to learn more about these various elements of work. I will just touch on the community policies for E4S. We're having strong impact and sustained impact by our teams themselves, deciding which elements of community policies are important for agreement so that the tools that they're developing can be used in a complementary way together. And only in those are we asking teams to develop new functionality in order to support these policies if they don't already have it. We're still preserving the ability for teams to do their research and their development in the way that makes sense for them. I'd just like to call out Jim Willenbring as the lead of our team who's working across software development kits. We are using this approach in the same way that I described for math libraries, also in other areas of functionality within ECP. So the policies shown here are at the highest level for E4S. So they're common across all of the software kits. One of the advantages of this approach has been to really streamline and help our science teams have much quicker builds. We've been able to significantly speed up the build time by a factor of 10 for a number of applications. Shown here is the fusion energy application, WDM app, which is using an E4S build cache, and consequently, the scientists, the fusion scientists who are working on this project spent less time recompiling and more time working on their science advances. We also have similar examples of speed ups for the wind application and many others. So just to emphasize, E4S really is intended to be an open architecture. We welcome anyone in the broad international community who would like to participate to do so. It's a collection of software, but it's not intended to be a monolithic set. Really, people can pick and choose which parts of it are needed for their particular use, and then work to the work that we've done in coordinating and testing makes it easy for people to pick and choose and use the parts that they need. So that's the end of the summary of work about software ecosystems. Would be a good time to pause for questions before we move on to discussing some of our work on software productivity topics.
Lois, we have 3 questions here.
Sure.
The first, you talked about the issue of providing incentives for all the non-technical aspects of software development. One important aspect is user support, for example, mailing lists, which can take a lot of time for large projects with many users and usually does not lead to any publications. How would you provide incentives to the community and researchers to help each other and to reward such time investments?
Well, that's such a great question, and I look forward to having a discussion with the whole group about that. And in fact, you're really providing a good lead-in to to jumping toward the end of this presentation. I personally feel that each of us has an opportunity and really an obligation to play a role in changing our culture in order to drive attention to the need for attention to these very important elements of software, high quality software, and in order to drive the opportunity for our teams to have adequate resources to focus on that. So I think there's no specific simple one answer, but I do believe as a community, we can be all very powerful within our own spheres of influence to collectively advocate for and lead change.
Next question, how do we help a student who has just been introduced to single core numerical algorithms ramp up to be capable of contributing to the ecosystem that you described?
Well, that's also a very good question. The challenge of appropriate accessible materials for learning about high performance computing is one that I know many people are thinking about and addressing. And I would say there are a number of good places to start to learn beginning material, but much more needs to be done on that front. So some of the elements of learning about good software practices can be certainly addressed by looking at material developed by the software carpentry people. That is a wonderful starting point, and I would absolutely encourage people to look at that for beginners if they haven't done so already. And as we move forward in this presentation, I can point out some additional resources as well. But good question.
Okay, another one here. The XSDK ecosystem has been built from the bottom up with many projects pre-existing. They all have different goals and plans. How do you coordinate their development? Do you see developers of one project contributing to another project?
That is also a great question. I think one key thing that is helping us to succeed with our approach in software development kits in E4S is to really firmly recognize and embrace that each software team, each product development team really does have its own incentives and priorities and modes of working. So what I think has been very successful is our groups have come together to hash out really what are the elements of commonality that are important, such as having appropriate documentation and testing and whatnot, and what parts don't need to be coordinated, so that each team has the latitude to do what it truly needs in order to advance its goals. So there's a lot of elements here that are frankly not technical, but sociological. So learning how as communities to do our work involving perhaps the insights from social and cognitive scientists to help us learn how to work more effectively as communities is something that has been started, but much more of that certainly could help us all.
The last question, I think, in this batch, Lois, are there any standard query interfaces for people to find a software package matching what they need? And I think the participants referring to XSDK.
Well, certainly the E4S site has an easy way to find documentation about all the various packages that are part of E4S. So I would encourage people who are interested to begin by looking there. There certainly is an opportunity to build on basic information such as that in order to do something that might be more complicated based on the particular needs of particular teams. Right now, this would require an individual to read about the functionality of the various products, projects, and then consider what to use.
Please continue, Lois.
Okay, thanks. So just another comment about the work we've been doing is that we are really working together across many teams who come together as an aggregate team, or in other words, a team of teams. So we have successful teams and applications in various elements of software who are working together. And I encourage people to take a look at this reference led by Elaine Rayburn. She's a social scientist who has been really helping a lot of us understand how we can more effectively function in these large aggregate teams. So of course, our contributions across the community require all sorts of input for many people. And I just want to raise awareness and attention to three kinds of people who are just so important in the work that we're doing. So I already mentioned how impactful our social scientists are and opportunity there. I want to mention that we have really important contributions by project coordinators who are helping our teams handle planning and logistics, which is very important for more complicated hierarchical projects such as ECP. And then, as you can see in big dark letters here, the research software engineers in our community are pervading all that we do, and really are for the most part the key people with the special technical expertise who are often bridging between teams and helping application teams and software teams to collaborate together effectively through software. So we have a variety of research software engineers who, some of them have more application-oriented backgrounds, grounded in a particular kind of science, and some have backgrounds that are perhaps more oriented towards software or mathematics. But each in their own unique special way are providing just critical fundamental advances in our community, and really their role only I see growing as we move forward with these higher complexity software packages. And to the point of research software engineers, I just want to call out a few wonderful research software engineers who happen to work at my institution, Argonne. There are many, many more in ECP, in other Department of Energy national labs, and the broader community. So if you have a chance, you get the PDF file of these slides. Everything that has a red underline is a hyperlink, so you can go and learn more about any of the red underlined information, including RSEs. So this now leads into an opportunity to talk about how we in the Exascale Computing Project are trying to deal with some of these challenges in developing high quality software. And the IDEAS project has been started prior to ECP, but has really grown into a central element of work in the Exascale Computing Project by helping our teams to identify some of the bottlenecks in their software practices and then work to overcome those in order to advance overall productivity and sustainability of software. This diagram shows 4 complementary elements of work in this project. That is creating and curating methodologies or information about software type practices, working with teams to improve practices, establishing software communities and community policies. We've talked about that already, and also engaging in broad community outreach. So I'd just like to mention that the members of the IDEAS project do have such strong passion for this topic and are grounded in expertise in application software as well as computer science and applied math. So it's really a privilege to work with this team who are all in some ways collaborating with and embedded with other teams. And we're working to try to do our part to help our community software be more effective and sustainable. This one slide is a deep dive into just one example of some work that is underway in the ECP project that's a partnership between members of the IDEAS project and a team in ECP. In this case, it's the HDF5 group, who are the developer, or the HDF group for the developers of HDF5. And here, the HDF5 developers partnered with Elsa Goncharovsky and Reed Milovich, who are members of the IDEAS project, to use a methodology to help the productivity and sustainability improvement planning, or PSIP methodology, to identify what they considered some of their bottlenecks and to identify steps forward to help make progress. So I encourage people who are interested to take a look at the hyperlinks here, which provide a summary article as well as a webinar explaining what the approach was and the benefits of the teams working together in this way to improve documentation, repository approaches, and also standards for coding. As I mentioned, outreach is another key element of work within the IDEAS project, and this slide just provides a pointer to a number of events that have been going on recently. There's a variety of tutorial materials that are available online. So as a partial answer to a question that came up earlier, these tutorial resources might be of interest to some people, covering topics such as, from a high performance computing angle, elements of software design, methodologies, workflows, testing, refactoring, and more. And how wonderful to be able to mention the webinar series that OSNI leads, the HPC Best Practices webinar series, in a webinar. So this has been a really fun and impactful series led by the IDEAS project. And there's an article that summarizes the first 5 years of webinars. So there's a lot of good resources across a variety of different topics. And we certainly thank OSNI for his wonderful work in leading the community. And we welcome all of you, if you're interested in providing input about the webinars, to please do so. We always are looking for suggestions for topics and speakers, and we would really be so grateful if you would provide feedback. Another aspect of work with outreach has been organizing birds of a feather sessions, as well as other events and workshops. In particular, last summer was the third installment of the Collegeville Workshop on scientific software. So those of you who are interested in this topics related more to software productivity might enjoy that. Though there will be another one coming up next summer. Also, we've used the format of panel series to very effectively blend together input from a variety of people. Last year, Anshu Dubé led one focused on performance portability, and currently ongoing, the panel series on strategies for working remotely, as led by Elaine Rayburn, is exploring not only issues with working remotely, but really beginning now to think forward about continuing to work over the longer term as hybrid teams. This panel series started when we began working remotely in spring of 2020, but actually now we're delving into topics that really relate more to multi-team, multi-institutional hybrid collaboration in a sustained way. So that's been impactful. One thing I realized I neglected to mention is that David Bernhold from Oak Ridge coordinates all the outreach in our project, and we're truly grateful for all that he does, because as you can see, outreach is really a strong and important aspect of our work. Another initiative in the IDEAS project is the Better Scientific Software site, which is intended as a welcoming place for the community to share information about software practices. We welcome all of you to contribute to the site, and we encourage you to read articles on the site. We do send a monthly announcement about new content on the site, so it's not a high volume mailing list. So please sign up if you're interested. And Rinku Gupta from Argonne is the editor-in-chief of this site. I'm sure she'd be really delighted to hear from anybody who might be interested in contributing. Another initiative of the IDEAS project is the Better Scientific Software Fellowship Program. This is a program that's intended to give recognition and funding to leaders and advocates of high quality scientific software. And this is coordinated by Hey Anam of Lawrence Berkeley Lab, and joined just this year by our new deputy coordinator, Elsa Gonczarowski from Lawrence Livermore Lab. So we're grateful that we started with support from the Department of Energy and the Exascale Computing Project, and last year also were able to incorporate support from the National Science Foundation, continuing forward this year as well. So one of the newest areas of work in the Exascale Computing Project overall is working to broaden participation of underrepresented groups. So this initiative is not limited to the IDEAS project, but here I'm speaking really on behalf of our whole community in the Exascale Computing Project and the collaborating computing facilities. We've started recently a task force on broader engagement, and I'm co-leading that task force along with Ashley Barker, Julia White, and Dan Martin. And together we have representatives from across the various labs and computing facilities where we've come up with a three-pronged approach. We're working both to help change culture across our community and to also create some accessible materials on introductory, getting started with HPC type materials, as well as working on an internship element in collaboration with Marianne Lung. So you may know that Marianne leads the Sustainable Horizons Institute, and she is indeed a well-recognized leader in our community who for many years has been pioneering approaches to broaden the communities who are involved in high-performance computing. And it's exciting that the Sustainable Research Pathways program that she has pioneered won the 2021 HPC Wires Reader's Choice Award and Workforce Diversity and Inclusion. That's very exciting. I encourage you to take a look at the materials hyperlinked from this slide. Really great work about sustainable horizons. We just this year are working with Marianne and her team to expand the concept of the very successful Sustainable Research Pathways program that she's been doing with Berkeley Lab, and to scale that across the ECP community. So for any of you who may be interested or may know of people who are students from underrepresented groups or faculty who are working with students from underrepresented groups, we encourage you to take a look and consider this program. So we'll be having opportunities for students and faculty who are working with students to collaborate with EC teams across our portfolio of work on applications, software, as well as facilities. So please do have a look. So now in wrapping up, I'd just like to summarize to say that I believe that now is a unique opportunity for our community overall to really consider thoughtfully what ecosystems make sense from the point of view of computational software, and just encourage people to consider taking a look at the E4S approach. Welcome feedback and participants, but we also recognize that lots of other wonderful ecosystems are being created, and those may meet some people's needs, better than E4S. So just thinking from an ecosystem point of view is, I believe, my main point I want to convey. And of course, in order to think from an ecosystem point of view, we need to have high quality software, but there are many complex challenges as we discuss. I encourage each of us to take a look at the material being created by these groups and figure out how you might want to leverage their materials and possibly how you might want to get involved. There are lots of opportunities, and I think it's clear that investing in better software really does pay off for each of us in many ways. So it's a good investment of our time. So as we think about this a little bit more, I'd like to go back to a question that someone raised earlier, and that is, how can we work towards change in our community? And I would say that each of us, no matter who we are, what we're working on, whether we're a student, an early career person, mid-career person, a stakeholder, a project leader, there are actions that we can take, and I think that we should really consider carefully about a call to action for each of us. So if you are someone who develops software and uses software, I would encourage you to think about looking at resources for improving your own software and advocate for and leading change in your projects. Each one of us has the ability to do that. We don't need to be the official project leader in order to investigate, think about new ideas, and communicate with our team members. That's something that each one of us can do, and I think should do. And then when doing so, it would be wonderful for individuals and teams to share their insights in software improvement from your own work. We certainly welcome people to communicate through the Better Scientific Software site, but also there are opportunities for communicating in other venues, conferences, workshops, and whatnot. And of course, please do check out community activities such as the Research Software Engineering Movement. For people who are leading teams or organizations who develop software, I think it would be wonderful for such people to really think critically about how to encourage your teams to improve software quality and to have time to improve software quality, recognizing that it really does take time. And we cannot always be in a race to just write the next paper or meet the next deliverable. We really do need to be able to invest time in continually improving our software practices. And at the same time, we who are leading projects and organizations need to provide very clear career paths and mentoring for scientific software professionals, such as research software engineers. For people who are stakeholders or supporters of projects that develop and use HPC software, this is a place where I think some of our biggest opportunities lie, and of course there are challenges, but I think we have an opportunity to incorporate expectations of good software quality and sustainability, and incorporating expectations for reproducibility and transparency. And not only have expectations that projects address these, but at the same time, recognize that funding is required for people to do this important work. So this speaks back to the question that was raised earlier. And finally, we all, regardless of what our roles are in these projects, can work together to work toward changes in credits, metrics, models, and incentives, training, and education. So there's a lot of work to do, but I'm very heartened because a lot of momentum seems to be heading in this way through many of these groups. And I'll just touch on a few opportunities for people who may be interested. The Leadership Scientific Software portal is a place where anyone is welcome to come to look at the conversation underway about working towards software sustainability. This is initiated by the software technology people within Exascale Computing Project, their monthly meetings and online information. And also there's a workshop coming up next week. At this point, if people are interested to participate as observers, you could do that. The submission deadline has passed, but observers are welcome. And here, although supercomputing is passed, is a list of a lot of interesting training events and BOFs, panels and whatnot that took place there. So it's exciting to see that there is such a broad swath of material at supercomputing focused on software topics. Here's just some further reading for people who might want to click on these hyperlinks to learn more about software in ECP. I'd like to point people towards some conference opportunities coming up in 2022 with SIAM and also PASS, and also a special issue that came out recently on innovative research toward the Exascale era. And finally, for an even deeper dive into software technologies, there is a document here that has lots of detail about each element in our ecosystem, and a report that provides a deeper dive into the work on software productivity and sustainability. And that's all. So thank you so much for the opportunity to talk with you today. I'd be glad to address questions.
Thank you, Lois. Yeah, very nice. So there is one question here. How is the ECP ecosystem compared with those of Japan and China? If you could comment on that.
Well, certainly there are many successful ecosystems being developed for scientific software, and we're seeing wonderful advances. And in fact, Supercomputing Conference recently is a great place where we can reflect on the advances from throughout many people throughout the world. So we're all taking slightly different approaches to building up the critical software that we need to exploit our machines. But I think there's some commonalities in regardless of what our nationality is or what particular machine we're working on. What I see are commonalities across China, Japan, Europe, North and South America. We're all sort of as an international community coming to grips with the fact that our software and scientific challenges and our hardware are all of such complexity that we really do need to pause and think about how to approach them in a way that considers the team aspects of what we're doing, the ecosystem points of view.
Thank you, Lois. We have a few minutes left here, so I would invite participants to unmute themselves if they like to ask questions directly to Lois. Oh, there is another question here, Lois, meanwhile. All right, so what would you say is the future of software publications? How can we give credit? The participants is still typing, but if you could answer those, how can we cite?
That's a very important question. There are a variety of efforts underway internationally to address this very important question. And I believe that getting involved and learning about those efforts would be good for each of us. As we know, there's the Journal of Open Source Software. There's also Software X, both places where software advances can be published. And then there's complementary work towards changing practices about promoting, actually citing software that's being used rather than overlooking the citing of the software when science advances are happening. So I think there's no one specific answer, but a blend of a variety of answers. People in the community who are working on various aspects of, like the fourth citation group, for example, is one. Dan Katz and others are really pushing the boundaries of what could help us as a community do a better job in being able to cite software and thus create the really important acknowledgements that we need for the creative and impactful work of the people who are designing and developing the software.
So good, Lois. Thank you. Any further questions from the audience? Again, I think we have 1 or 2 minutes left to hear if participants would like to unmute and ask directly to Lois. So I'm going to take the opportunity here, Lois, to take over and share my final slide.
Sure.
So thank you all for participating. So please help us improve the webinar series, giving us some feedback. The slides and recording, these slides are already available under that link. Recording will be there soon. And so this is of course, the last webinar in the 2021. Moving to 2022, the first webinar will be on January the 12th. Wrong way, lessons learned and possibilities for using the wrong programming approach on leadership computing facility systems. Represented by Phil Roth from Oak Ridge. And we have already a website there with more information. People can sign up. Any additional questions from the audience to Lois?
I would just like to thank everyone for carving time out of your busy day to come to this webinar and really welcome everyone's creative ideas for moving forward. Thanks for all the work that you're doing.
Thank you, Lois. Oh, here, another one, a final one here. How do we become members of the ECP project?
Well, that is an interesting question. I would say, at least as for anyone who's interested in learning more about ECP and opportunities, I'd be glad to chat with you about that, to let you know about some of the things that are happening. There's not a quick answer. There's not a, go to a certain website and click on something, but I'd be glad to have a conversation.
So that was a question from Lucien, Ivan. So Lucien, yes, I think we could take the opportunity to contact Lois later. So thank you all for joining us today. Thank you again, Lois. Very nice presentation.
Thanks so much, Ozzy.
All right. So happy holidays in 2022 to everybody.
Thank you. Bye-bye.